Yeah. So in our last class, we were dealing about word embedding techniques, right? We have seen various embedding techniques also. The most popular embedding techniques we have seen is like a word2vec and also glow. In word2vec, we said that we have got in two flavors, continuous bag of words, and then like another one is the skipgram, right? We have seen. And also similarly in continuous bag of words, we were discussing stating that like we try to give the context words and then we try to predict what is the predicted word or how to what is the next word that comes into picture with respect to this particular context words. Whereas in skipgram, what we try to do is simply we give the word and then check or pair it with each of the context words. If they are into the context, then we represent that one as like S, the output is S, they are in the same context. Or if they are not in the context, then it will represent as not context or something zero is the output for that one, right? And also we have gone through stating about the glow. Like a word to vec, we said that it mostly considers about the local vectors and local context, whereas the global vectors glow, it considers about the global positioning or global vector. It takes the consideration of the global vector with the help of the co-occurrence matrix, right? That was what we have seen. These two popular methods we have seen. And also we have suggested that there are also some advanced embedding techniques like fast text, random walk, star space. Like these, there are uh, additional embedding techniques, and you can go through the literature if required. And today's class, from today onwards, we'll see mostly the sequence processing activity. Okay, uh, this like in natural language processing, mostly the data are in terms of sequences only. If I speak something, okay, or if I write something, the set of words that comes is in a sequence. I am a boy, boy, I am. So see, this is not, it may not give a correct meaning here only because you are able to semantically you are able to extract it. It's fine. But what about things when it is semantically that cannot be extracted? So, means jumbling of the words here and there and then giving it. Of course, there were some situations or some words which say that like if the beginning and the end words or characters are like absolutely in the right position, maybe like there is a possibility that like we can predict to a greater extent that like we can extract the right word. Similarly for the sentences also, but that is maybe like it requires a little bit of higher intelligence and higher processing. Whereas conventionally we use sequential processing, right? See, most of the real world problems are sequential in nature. That is, the order of the event matters a lot, right? So if you take example of a speech, the order of words matter in translation of a language or of a sentence. I'm speaking. Suppose I am speaking. If I use the words here and there, now let us see that the same sentence written here, the order of words matter in translation of a sentence. Suppose I give it, so only these words only I will use it, but I will give it in a jumbled way. Words translation order of a of sentence the. If I give it like this, how do you understand that? Right? It is difficult for you to understand. It means that there should be some order. It means that there should be some sequence. Okay, and one followed by the another word like that. Or another example is with respect to an activity. See, order of the movement of a system defines different activities. Suppose I say that I am running. Okay, running. Possibly like what is the order of the activity? Maybe like if I am running mostly, like maybe like if you are running fastly, mostly on the toes only will be running, right? Will be running on the toes and all. So the uh, movement means taking the leg from back and putting it on the front and then towing it, and then afterwards taking the leg again, another leg from the back and throwing it on the front. And suppose this is the order for running or front walking. What is the walking? If you are simply telling that you are walking on the forward, okay, what does it matter? Here it means that you take your steps forward, then move front, again forward and move front. Okay, so sometimes what happens is that in this process, when you take your right leg and put on the forward, it means that your back leg is on the back side, and then you take now your back leg and put it on the forward and your right leg is back. So it means that front, left, left, left front, left back, sorry, right front, left back, left front, right back. So this is the process that you go. It means that there is an order, right? You cannot destroy that order. So for activities also, we can see, or some videos, this can be modeled as again sequence of images. If the sequence of images are not correct, then what happens? See, what is a video basically? A video is a sequence of images, right? Maybe like a 30 frames per second, maybe like that it comes. Okay, so how many these images in a single second, maybe like how many frames of these images comes into picture? Suppose it gets violated. Okay, the first one, suppose you can see that like there is a handshake. Okay, there is a handshake. If the hand one person removes from the just from his pocket, and then he gives the hand to the other person to shake. Suppose in between, like the sequence is given here and there, the set of frames are played here and there rather than playing in a sequence. Imagine that this that will become a great havoc, right? So because sequences mattered here. So you can say that, okay, conventional feed forward networks, neural networks, if we use it, this sequence cannot be preserved, right? So in order to overcome that one, we need to use some other neural networks or some other techniques or some other strategy or some other method networks. Okay, so we will see like what are the problems with the forward network. So they are not capable of handling the sequential data. They are not capable of memorizing the previous input data. So it currently depends only on the current input only. About the current input only it will take into consideration what was the previous input. And so in that case, sequence, suppose I speak a word, I am a. So after I, what is the word? Am. Okay, what after uh, am, then what is the word? A. What is after a? What is the word? Means only it takes into consideration about the very local property only. So this is the main problem with this feed forward networks. Okay. So if you see a recurrent neural network, uh, you see on the right hand side, you just see it, this one. Okay. This is a general representation basically. Okay. The first thing that is given is that this is a general representation. You see the input at maybe like x naught. Okay. The x naught is the, or x0 is the input that you give it. Then here some activity takes place. Okay, some activity takes place here, and then the output is given as h naught. Similarly, you try to give it input from this x0 also, you forward or pass it little bit forward to the next layer. Okay, so at x1, okay, maybe like at a time t1. Okay, this is a t0, t1, t2, t3, t4, like that. Okay, assume that. So at time t1, then what happens? The x1 input along with the input of this x naught, okay, is taken, then the output combinedly, some output is given here. What about the input at x2? From x1 also it considers, and then it gives the output, right? So you need to understand that feed forward networks, the output at time t is independent at the output of time t minus 1. There is no relation between the new output and the previous output. So in feed forward networks, the outputs are independent of each other. What about this? What is the solution for that one? Is recurrent neural networks. So there are situations where you need to get the previous output to get the new output, right? Previous output also is required. The previous output also is required to get this particular output because of the dependency issues. So example, you can say that like some prerequisites for some subjects maybe, like suppose I say that suppose you need to know about simply about maybe like a some Pythagoras theorem, or maybe like some advanced trigonometry and all. So you need to know about what is the value, or what is the formula for cos, what is the formula for sine, what is the formula for tan, or like this, right? These basic geometrical values should be known. These are the prerequisites for the advanced concepts of trigonometry, right? So predicting the next word in the sentence in NLP, when we take it, predicting the next word in the sentence, the word depends on all the previous words, right? And this can be in a general representation, it can be given xt. It means to say that this input, you do some processing activity, and then gives the output, and this activity is carry forwarded. The processed activity, the output of this particular input is carry forward, and for the next input, the previous output is also taken into consideration. This is a general representation. So you can say that RNN is a type of artificial neural network that is used to recognize patterns in sequence of data. You may take it either it is a textual data, or genomics data, or maybe like a handwriting, or maybe spoken words, or sometimes this mostly the time series data, like either weather forecasting data, or maybe like the stock market data. All this, okay, any time series data also directly they comes under this sequential data. Now if you take a small analogy, okay, let's take a small analogy here. Suppose you were put up in a hostel, and your mother instructs you to take some daily tablets or nutritions. Assume that those nutritions are available in fruits, and mother says that at day one, okay, day one, you have to take it the apples, okay, apples. At day two, okay, day two, you take bananas. Mother says that you take bananas on second day. And day three, you take oranges, okay, to boost your immunity, okay, oranges. So assume that your mother is very much concerned about your health, and she tells that in day one you take apple, next day you take banana, next day you take oranges. Okay, again you repeat this order. Okay, again on day fourth you take apple, day fifth you take it banana, day sixth you take orange, day seventh apple, banana, and oranges. You just repeat this mode like this. So like predicting the next day fruit in the menu, how we can predict? Suppose like 1 2 3 4 5 6 7, like that, that is on this day you have to take this, on this day you have to take it. It is like this. So uh, it is given well that suppose day one you have taken apple, okay, you have taken apple, then on the next day you are supposed to take banana. So on day 2, or maybe like the day you have taken banana, the next day you have to take it orange. The day you take orange, you have to take it apple next day, right? This is the sequence. So even if you were absent for few days, assume that maybe like you were absent for few days, the input can be fed to the new network, and the next value can easily be predicted, right? Suppose on 10th day, what are you going to take it? 10th day, it means that ninth day what you have taken. So ninth day is determined by eighth day is determined by seventh day is determined by sixth day, sixth is determined by fifth day is determined by fourth, and third, and two, and one, like this. So you know that based on the sequence, you can determine what type of this, or what type of route you are supposed to take it. So it means that there is a sequence that need to be maintained, and how that sequence has to be maintained. So here the thing is that if you simply model this one in terms of vectors, and then you give it to a neural network. Suppose this is okay, suppose you give it in terms of a vector, maybe like you make it this one as an apple, banana, and then this is an orange. So this is the new stuff that you are supposed to give it, and you give it to the neural network. Okay, you give it maybe what so this one apple means maybe like this is, suppose you are giving it like this. Okay, simply we are giving it. So this determines this one, so this determines this one, and then if this one is there, then you have to take it this one, suppose. Okay, assume, let's just assume this one. Okay, so information from prediction at time t, this is the info. Okay, this one is nothing but this vector is the information at time t minus 1. This is the new information that you are trying to produce it. Okay, new info at time t. So now you are trying to predict at time t. Okay, at time t, what are you going to take it here, what should be your this one. So what you do it based on the corpus again. So this output you keep it, right? You keep it this output, and then this is the again. So if it becomes, if it is t output is given here, fed here, then for t plus 1 you are going to use this one. Okay, for t plus 1, t plus 2, so t plus 1 data again you store it back, and then t plus 2 data you can. So along with the new information we have the previous information also, right? This is the way, this is the way how it can be modeled. This concept like this, it can be modeled into a neural network, right? Now assume that this is what we have given here. Okay, uh, so you can just see it that x naught is the input, and to get this h naught, okay, you multiply this wi, the weight, with this x naught at this, at a time x naught, or a t naught, t0. You multiply this input with this is the input. Okay, this is the input, and this is the weight, and then you try to attain this w, h naught. Okay, after processing, okay, after processing, then you try to send the processed value for the next. Okay, you can keep it for the next, or you, and also you can give the y naught with some weights wy at x1, or time t1. At time t1, this is t naught, at time t naught, at time t1, and time t2. Okay, at time t1, what it does, this one is multiplied, x naught means x1 is input, and then wi, it is multiplied again not only this value, but also it adds the value of WR also in the process of forming this H1. Okay, attaining this H1 result, and then the output, the processed output WR is given for the next stage, and then Y1 is the output given here with some WY as the weight. So similarly for this one at T2, X2 WI, and then you are going to use WR to get H2, and then from this H2 you get the Y2 with some weight. Okay, weight of Y. So this is the process, right? This is the process. Now, how does a RNN work basically? So if you give that mathematical equation for that earlier, whatever we have seen this for this one, okay, if we give a mathematical equation, that is, so Wi into x, okay, Wi into x at that particular time, okay, at that particular time t. Suppose you are trying to find out ht, okay, h of t. So you are trying to find, assume that this is h of t, okay, ht, okay, ht you are trying to find out, or it is given here h up, it is given here h of t. Okay, suppose you wanted to find out this one, then what you are trying to do, wi x. So here wi x naught means this input multiplying plus wr h of t minus 1. So initially you do not have any input from earlier things. So that's why this becomes a 0 1 plus the bias of h. This is passed through a function gh, and then the h of t, or the h value is attained here. This h value is attained here. Now to get the output, what you do it? Why not? To get the output, wi into h of t. So wi into h of t. This is h naught. You are going to give it plus some bias by. They pass through a function gy, and then y of t or yt is attained here. So similarly in the next process, what happens here? Here what happens now? So here now t minus 1 is there. Okay, t minus, so wr into h, t minus 1 value is available. It means that next time you are going to add this one. First time it is not required, okay, but next time onwards you have to add this one. First time it becomes 0 because time it cannot go back, and then like that value, if current time is there, or like the x naught is there, x naught means minus 1, time cannot be in minus 1, so this value becomes 0. So this way you have to process completely, or this is how y0, y1, y2, all these inputs are attained, or the outputs are attained for the inputs x0, x1, x2, and this comes in a sequence. It means that suppose you wanted to predict y2, does it only depend on x2 and its weight? No, it depends something on wr, which is taken from this h1, right? It is taken from h1, and this h1 depends on t1, and also it depends on wr or h0. So this is what it is said, that the sequence of the words is dependent. Okay, how far it is dependent. Now one thing what we try to do, we try to get the output wyt or something like that, and again we compare with the error, right? We compare with the actual output, and then now we try to go for back propagation to, if there is some error. How error is calculated? In the process of training the RNN, the back propagation algorithm is used for every timestamp or every epoch, like that. Okay, now you see error E is equal to actual output minus the attained output. E is calculated. Okay, the E is calculated here. Now E is error here. Okay, E is error. Please just understand that. So now you take the change in weight delta W is equal to n into, n is the learning rate here. Okay, n into this is basically the change in error. Okay, this is the change in error. Change in error with respect to the weight, or you can say that this one as a gradient. Gradient or rate of change in error with respect to the weight. Okay, delta W is calculated, is taken as n into the learning rate into the gradient. So this is delta W. Now the new weight W has to be, because after back propagation the weights has to be adjusted, right? How it is adjusted? W equal to W plus the existing weight plus delta W. So this is the process of back propagation. Please understand that. Okay, this is the process of back propagation. Now in back propagation we have got basically two issues, two major issues. What are those two issues? First one is the gradient, vanishing gradient, and second one is the exploding gradient. What is this vanishing gradient and exploding gradient? Vanishing, as you can say that the both the names suggest, vanishing means diminishing or very negligible, like that. Exploding means that things that something coming very big. Okay, big gradients or very negligible gradients. That is what is vanishing gradient is, negligible gradients, and exploding gradient is very big gradients. So this is, if the gradient is very less, it means to say that if dE by dW, the rate of change of the error, okay, the rate of in the error with respect to the weight is very less. It means that less, very less than 1. Then you know that if this is the, as per the earlier equation, if this is less, then this one into basically the learning rate will be 0.05 or something like that. It will be very less. So learning rate will be very less. So this less into this less becomes this delta W. So delta W will be also very less, right? Then automatically delta W also will be very less, very less with respect to 1, compared to 1 also. Okay, and if this delta W is less, then you can understand that new delta W also will be, new W also will be new weight that is assigned also, that that is to be adjusted also, is very less. It means that suppose you see that the weight taken initially is a 2, okay, and the adjusted, new adjusted weight is a 2.00000001 or 0.000003, like that. What is the change that you are going to get it, right? So this is basically vanishing gradient. Okay, vanishing gradient. So if there is, if we want a long dependent, like a, long dependency word, okay, then it is very difficult to attain or to get that particular context. Suppose there is a sentence like this, for example, I live in Odisha for 15 years, or let me write it down for you. Okay, this, whether text is there available here. Okay, I'm suppose I write it here like this. Okay, now I write it here like this. I lived in Odisha for 15 years. I had very good interaction with the local people. I used to always chit chat with many of them every day. every day. I can easily speak. So what should be the word here? What should be the word here?
Odia.
Yeah, it should be Odia because you know the context. You are understanding the context. You took the context that I lived in Odisha for 15 years. So maybe like something I speak, something related to a language that language is associated with this particular state. So that's why you are telling that yes, I can speak Odia. This context, suppose it is like the learning rate with the uh, change of, or maybe the weight is very less, means it is very negligible. Where you are going to see it, you keep on checking with the nearest word, or how much you are going to check it and how much long you are going to. For a long dependency sentences, it is very difficult to get. Okay, it's very difficult to get this particular word, reach that. Okay, basically it is like, again, let me say that you as I said you, is that suppose this is your target point. From here, suppose slowly you are coming down like this, it is coming down like this. So when you are going to reach here, okay, so this is another the issue is like exploding gradient. What is this? If dE by dW is very much greater than 1, then delta W, change in weight, also will be very high, and then the new weight also, it will be very high. So every time you can see that the result will be very high. So you can say that, like in the vanishing gradient, for predicting the next word, we need to understand the context, that is the long term dependency. So in long term dependency, you can say that this rate of change dE by dW becomes very small, and change in weight is very negligible, and then you can say that results is almost no learning, right? Where you are going to learn it there. So this is basically the vanishing gradient. And if you say about the exploding gradient, here the new weight will be totally different from the old weight. Exploding because the values are something so different that every time it is changing, and then the new weights are totally different than the uh, so due to this one, there may not be any learning. So as I said you that, like from here to here to here to here to here to here to here, sorry, here to here to here, like this it will be roaming, but maybe like you cannot come to a conclusion here. So this is the problem actually. So some solutions that are being suggested are like vanishing gradient. For vanishing gradient, choose a smaller timestamp. Okay, rather than taking the context, long context, you try to take a small context, maybe like a timestamp from very small context, small context, and then you try to work it out. You clip the gradient that goes lower than a given threshold. Maybe like you can give a threshold also for the gradient, and you, this gradient should not go below this value, and you adjust the learning rate. Okay, you adjust the learning rate. So this is about, you can adjust the learning rate. This is, sorry, this is exploding gradient actually. Okay, sorry, adjust the learning rate. It has to come here actually. Okay, for vanishing gradient you use this. Okay, for vanishing gradient, you take these 2 points and then this point. Okay, third one as this point. Please use LSTMs or GRUs to overcome this vanishing gradient. For exploding gradient, we can choose a smaller yes, we can this is sorry, this is clip the gradient that goes here lower than threshold, and this is vanishing gradient. Please make a small correction here. For vanishing gradient, you use ReLU activation function that gives output as 1. Okay, and you clip the gradient that goes lower than some threshold. Still you can use this LSTM and GRUs. For exploding gradient, you try to use a smaller timestamp. Okay, then you clip the gradient that goes higher than the threshold, and you can adjust the learning rate. So this way, keep on adjusting the learning rate. So this is how you can overcome the exploding gradient. Okay, and various type of RNNs and its applications, as you have seen earlier also, that it is given here. And from tomorrow we will try to see the uh, like LSTM. Okay, we'll try to see LSTM and its this long short-term memories or gated recurrent units. Okay, that we will see it mostly like a long short-term memory. We'll try to see it tomorrow. Okay, with various this gates and then this cell. Okay, so this is up to today. Any questions you can ask me.